Hello, I will be making this video about testing a claim about a standard deviation or variance. Again, this video is for my students who are currently taking my stats and probability course, but if you come across this video and you can use it or you gather things from it that is helpful, please be my guest. So I'm just going to run through a few of these slides, and hopefully this will help you get a better understanding of how we test a claim about a standard deviation or variance. So let me just click here. All right, so the objective is we want to test claims about sigma or sigma squared. So conduct a hypothesis test of a claim made about a population standard deviation sigma or population variance sigma squared. All right, so this is the notation that we're going to be using. N for sample size, like we've been using. S is the sample standard deviation. Sigma is the population standard deviation. S squared is the sample variance, and then sigma squared is the population variance. Remember, we use Greek notation for population, and we use often lowercase letters to denote or just letters in general to denote samples. Okay, so two requirements for this test, just like all the other tests that we've talked about before. It needs to be a sample that is a simple random sample. And then two, the population has a normal distribution. So this is a fairly strict requirement here. Okay, so here's the formula for test statistic. This notation here, I'll try to, give me a second here. This is chi-squared. It's pronounced chi-squared. And how we calculate it, we do n-1, which is the degrees of freedom. Degrees of freedom. If I can get my pen to work right, degrees of freedom times the variance, the sample variance divided by the population variance. And again, to use the p-values and the critical values, I'll show you how to use that in the Excel template that I have for the class, or if you're not in my class, you can use the any table that comes with a statistics book. They all have it. Or you can use Excel if you see some formulas. Let's see, so properties of the chi-square distribution. So all values of the chi-square are non-negative, so notice that we stop here at 0, right? And the distribution is not symmetric. So symmetric would be that standard normal distribution curve that we've been looking at, that bell curve. You see here, this one is actually skewed to the left. Okay, so there is a different chi-square distribution for each number of degrees. So just kind of notice how for the degrees of freedom of 10, a lot more narrow towards the top, and then with the degrees of freedom for 20, we came down a little bit more. So it looks like there's less spread of data once we have that degrees of freedom 10, and then there's a greater spread of data as the degrees of freedom increases. Okay, so properties of the chi-square distribution. Again, degrees of freedom is just n-1. So let's go ahead and look at this example. Here we have the p-value method, which is what they're going to be asking for in the homework, which here we have do supermodel heights vary less. So listed below are the heights in centimeters for the simple random sample of female supermodels. Use a 0.01 significance level, so our alpha is going to be 0.01. Okay. To test the claim that supermodels have heights with a standard deviation that is less than, so less than here, well, we already know that our null, again, our population parameter is sigma, so, and our null hypothesis is always equal to, is going to be 7.5, okay, and this less than means that sigma is going to be less than 7.5. So this is going to be a right tail test. Sorry, not a left tail test. I'm sorry. For the population of women, does it appear that the heights of supermodels vary less than the heights of women from the population? So here we have a data set. And unlike when we were testing for the mean, we're going to test for sigma. So once I plug this data set into my Excel document, I'm going to want to find the sample standard deviation to plug it in. But this is going to be my testing claim here. This is going to be my null, and this is going to be my alternative. Okay, so again, the requirement check is that this is a simple random sample, which it is. Requirement check 2, we're checking for normality. So we see that the sample has no outliers. The normal quantile plot shows points that are reasonably close to a straight line pattern, and there is no other pattern that is not a straight line. Again, they're just kind of talking about the technology. Okay, so as I've already stated earlier, these are my claims. My null is that sigma is equal to 7.5 centimeters, and that sigma is less than 7.5 centimeters. So there's going to be a left tail test. Now I'm just going to go back to our problem here. Just kind of show you how I would do it in Excel. Kind of split my screen here. All right, so if you're in my class, you're going, if you already look inside the Lao Cloud portal, I already talked about that we want to use the variance standard deviation. I don't think I can draw it. So we really want to make sure that we're using this variance underscore standard deviation test. Your tab at the bottom, and we're going to want to use this one right here. It's a significance test for a variance and standard deviation. Okay, now so I have this data set, so I'm just going to go ahead and plug in this data set, so bear with me here for a second. Oops. Wait a minute. Oh, I see. Okay, sorry about that. Okay, so 178, 177, 176, 174, 175, 178, 175, 178, 178. Let's see, 180, 180, 178. Okay, let me just count these up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I should have 16 here. Oops, it's because I still have it on draw. There we go. Alright, so I do have 16 counted. Alright, so I think we're in good business. Okay, so I'm going to want to do equals standard deviation for a sample. Okay, so I get 1.843909. Now again, this is my sample standard deviation, so I'm going to want to change this to equals this guy. Okay, now in the problem, I know that sigma is this guy right here. For my hypothesize, so I'm going to plug in 7.5. And then n, well, I have 16, so I need to change 5 to 16. And then I'm checking with a claim of 0.01, or alpha is 0.01, so I'm going to change that. Okay. So when I do, I get a test statistic of this guy. And let me skip to that. Sorry here, there we go. Okay, so our chi-squared is going to be 0.97907, which is, if I round this up, that's what I will get. So this will be my chi-squared. Notice I was looking for a left tail, so I'm mostly interested in this guy. Right? And then from my decision, I know that I need to fail to reject. So there is not enough sufficient evidence to support my alternative that there's a less height, so there could be another option for her. We don't know. We have to run more tests. But let's see. Yep, that is it. If you have any other questions, please leave a comment or reach out to me in the LoudCloud forum.